BC Calculus, Lesson 6.4, the Fundamental Theorem of Calculus. That sounds like a big deal, and it really is. However, for the overwhelming majority of calculus students, it's just another thing to learn. What it does is it ties together integration and differentiation, and we bring it in two parts. The first part is that if f of x is an antiderivative, then this is how we define it. A lot of people say, well, what's this a value? And I say it doesn't matter. We imagine this is x from a to x. Because mind you're going to take the derivative. We would get x squared over 2 from a to x, and that would be x squared over 2 minus a squared over 2. Well, when we take the derivative of that, we just get x, because the other one's constant and it drops out. So this is the first part of the fundamental theorem of calculus. If it's continuous, then the function has an antiderivative, and it has a derivative every point, which is just the function itself. So why is it a big deal? Well, every continuous function is the derivative of some other function. That's kind of wild. Every continuous function has an antiderivative. We really struggle hard to find them all, but every continuous function has an antiderivative. The process of integration and differentiation are inverses. I'm not so sure I agree with that phrasing, so be careful with that one, but the other two are the big deal. And it's really that simple. I mean, take the derivative of this. This is a constant. This is just x. So we're going to get cosine of x. Remember, t and dt are just what we call dummy variables. Same thing here. Take the derivative, and we're going to get 1 over 1 plus x squared. That's it. Now, of course, we do our best to make it more complicated. What if we had x squared here? Well, I would substitute, and I'll never do it this way again, and take the derivative of that. So that we're actually going to say, what's the derivative of the integral from 1 to u cosine of t dt? And you would say, well, that's just cosine of u. But we're taking the derivative with respect to x, so we have to chain rule it. So du dx is 2x. And we just used the u to get there. We have to put that in, so I'm going to put the 2x out front. Cosine of x squared. So when you have a non-one derivative, for example, the derivative of x with respect to x is just 1. If you have a non-1, you have to chain rule that variable and watch out for it. What if there's a variable on the bottom? Well, that's easy because we already know this. Flip it and slap a negative out front. So dy dx equals negative 3x sine of x. And over here we break it up. We go from 2x to 0, 1 over 2 plus e t dt, plus from 0 to x squared. A lot of people look at it and go, how do you know 0 is between 2x and x squared? And we don't. 2x might not be. But if we follow the rules, it will work. So it doesn't really matter how we break it up, as long as we're consistent and follow the rules. For example, I don't like this. I got the x on the bottom. So I'm going to make this a negative and flip them. And I was going to say I'm not going to write it out, but I will write it out. And this one I'm going to do, since I can, it's just going to be chain rule 2x, 2 plus e to the, whoops, x squared. And while I'm at it, I'll finish this one. I'm copying this one down from here. 2x over 2 plus, I feel like I'm making a mistake, I think I'm not, x squared minus 1 over, whoops, chain rule it, derivative of 2x is 2. 2 plus e to the 2x. A lot of people look at that and say, oh, they're pretty close on the bottom, can I run with it? Don't. You don't have to. And, in this case, you actually can't. So, we'll get questions like this. Find a function with the derivative of dy dx equals tangent of x. In other words, find the integral. Tangent of x, pardon me, and this is the x value, this is the y value, so we go from the x value 3 to x, and our constant is 5. That's wildly confusing. It'd be a lot easier if we could actually find the integral of tangent of x, and we can, just not yet. So don't get hung up on that. We'll come back to it. This is the actual integral. And we'd have to check. We'll take the derivative. I haven't done this yet, so I'll probably screw it up. 1 over that would be cosine of x over cosine of 3 times the derivative of cosine of x is negative sine of x. And then the derivative of that is gone. And you look at all this and say, well, this doesn't really help me, does it? And I say, no, it doesn't. So, again, we'll figure this out later. And I'm kind of curious how I screwed that one up so bad. I wonder if I wrote it in wrong. Nope, wrote it in right. I have to do it another time. Very odd. So, this is an exercise, and I'll leave this open for a second, you can use to say, yeah, I don't have to find that derivative, which I just butchered up above, and I can just put it in the calculator and go to town with it on the NINT button, N-I-N-T button. But if you follow this exercise, you'll see it's not quite that good. So this is a little bit beyond the scope of what I want to do here, but it's not a bad idea for you to try. So rewind and check it out if you have to. Now here's the more important part of the theorem of calculus, fundamental theorem of calculus for the purpose of computation that we're going to do. If f is the antiderivative, plug in b, subtract, plugging in a. And that's it. So the antiderivative of this is x to the 4th over 4 plus x, and we do this cool little notation where we say from negative 1 up to 3. And that just means 3 to the 4th over 4 plus 3 minus 1 to the 4th over 4 plus 1, which is 81 over 4 minus 1 over 4 plus 3 minus 1, which is 80 over 4, which is 22. And then if you haven't figured out how to do this already, go watch one of the previous ones, but you put it into your nint. You say from negative 1 to 3. You put in x to the 3rd plus 1. And if you're like me, you forget to fill it all the way out. You put your x variable in at the end. Hit enter, it says 24. So, my bad, I subtracted 80 over 4 is 20. That's negative 1. Naughty, naughty, naughty. That's why I checked. So this gets 24 because this is plus 1. Right. So, application. Find the area of the region between these curves. I have to graph this. 4 minus x squared. I go up here and Here's 4 minus x squared. Here's 3. Here's 2. So the area between that and the curve, I'll make it a little bit uglier, looks something like this. Here it's 0. So if I take the integral with my calculator, it's not going to work, because it's going to take the positive value, the negative value, and just kind of combine them. It's going to cause major chaos. So I have to break this up. Integral from 0 to 2, 4 minus x squared dx, minus, because this is negative, integral from 2 to 3, 4 minus x squared dx. So I get 4x minus x to the third over 3 from 0 to 2 minus 4x minus x squared from 2 to 3, and we go to town on it. I'm going to start shortcutting things. 8 minus 8 thirds minus 0 minus 12 minus 9 minus 8 minus 4. I say, wow, what a mess. But we can do a lot of simplifying over here. That's 4. That's 3. That's negative 1, so it's plus 1, because it's minus minus 1. Seems off to me, but okay. I feel like I've made a mistake in here. Well, let's just keep going, see where this takes us. And over here it's 8 minus 8 thirds, which is, well, let me do the 8 plus 1 is 9 minus 8 thirds. So 9 times 3 is 27 thirds. Yeah, I'll just do it here. 24 thirds minus 8 thirds. I'm going to change this to plus 3 thirds. All said and done, we get goodness gracious, I didn't do this derivative right. That's upsetting. So let's try that again. 3 thirds 27 is over 3. Humorous. Still 9. 2 to the third is 8 thirds. So this is 3 and 16 thirds. 3 minus 16 thirds is 9 minus 16 thirds is 7 thirds. Equals 23 thirds. Sorry for the mess. So how about doing this with the calculator? Well, it's tricky. I'm going to have to put up my calculator here in a second. And we'll use this one to show what we're talking about. The problem is all those negative areas. How do you get the calculator to do it with positive areas? So, calculator is going to be giving me a little bit of a hard time here, so bear with me. Fit in it as best we can like that. So y equals, and we're doing x cosine of 2x, x cosine of 2x, and let's set the window from negative 3 to 3. Negative 3 to 3, and graph it. So notice we go above and below and above and below and above and below. Runs off screen a little bit to the right there, but you get the general idea. So how about we do this? We go absolute value. Let's go down one. X cosine of 2x with that. You'll notice it stays completely above, and it reflects the parts that were negative, so that we know we'll get the exact right area. So if we were to use this math 9 from -3 to 3, go math absolute value x cosine of 2x x. Notice it's going to take a second. Calculator has to work a little bit to get this done. I find that fascinating. And then it finally pops up our value, which is I believe 5.43. My calculator goes faster than those. 5.425, I should say. So this is the rule. Use absolute value. Same time, be careful. Area is 5.425. Just make sure you know what you're doing. So now we did a little bit of spec in Unit 5 where we analyze graphs, and we say the graph of f to the right is the derivative of h of x. In other words, h of x is the integral of f of x. So watch out, we define it over 1. We say find h of 1. Well, the integral from 1 to 1 of anything is 0. Which means that if we look at h0, we say, oh, that's a positive value, but yeah, we're finding the integral from 1 to 0, meaning it's backwards, meaning it's the negative if we do it the other way. So we're going to say it's negative because the area is positive and we're going backwards. Zoom out a little bit here, see what we're doing. Find the value for which h of x is a min. Well, this is the derivative, so the derivative is positive from 0 to 4 and negative from 4 to 8. So when the derivative goes from positive to negative, that's a max. Took the integral, we could find out what it is. If we consider the min, it's at an endpoint, and we'll discuss that in more detail another time. And the points of inflection are just where the zeros are, so we're going to get points of inflection at 1, 4, and 8. That is a boatload of material. Good luck. Don't know what else to say. But as always, happy mathing.